Hi, welcome to episode 7 of my Figura tutorial series. In this episode, I'm going to be going over advanced scripting. Yeah, this is not going to be a great one, I'll be honest with you, but this kind of stuff is important to know for the later videos and later topics. So let's just try and get through it. Alright, let's get started. First thing I want to do is expand on the math library a little bit. This is stuff that you should probably be fine researching yourself, but I think it's important to explain some things that I had skipped over. Okay, so the first thing I want to show you is Modulo, which is this symbol here. It's quite an important part of, like, scripting maths. What Modulo does is it gets the remainder of, like, a division. Here's a bit of an explanation here, but I really don't think that's an intuitive way to describe it. It's like, if you do a division, what's left until you reach the number again, if that makes sense. So if we did like 1 modulo 10, give me 1, go like 5, it'd be 5, 8, 8, 10, goes back to 0, 11, 1, 14, and 4, etc. And you can do this with whatever number you want. It's just a good way to like loop. I think the best way to show this is with like looping in the world time. Well, I get time percent, I go 20. You can see it loops at 20 constantly, even though the actual value is like a crazy big number. Yeah, modulo. Very good to know. Alright, the next thing I want to show you is just math.floor. Another thing from the maths library. Really simple. So let me just log a number with a decimal to the chat. So in this case, I'll just go like 2.25. Doesn't really matter. If I were to apply math.floor to it, so that's math.floor, put it in the brackets, you can see it just rounds it down to 2, and this will apply to any decimal. What if you wanted to round up though? There's an option for that too. You can do math.ceil, which is supposed to be like ceiling. That's what that's short for. And so whatever decimal you type in here, it'll round up. Now this is great, but it is a bit limiting. Like, what if you don't want to round to the nearest whole number? What if you want to round to a decimal? Well, that is really simple as well. To round it to a decimal, you literally just need to multiply it inside the function by the amount of decimal places you want to move the decimal, and then divide it back again outside the function. Say we wanted to round this number to 2 decimal places. All we'd have to do is times this value by 100. Times 100, there you go, we've got that value there. Divide it back again by 100, and you can see it's rounded down 2 decimal places. So yeah, however many places you want to move the 0 is however many zeros you add here. It's not really complicated, it's just maths. Alright, so we have a value here. Now, say we don't want to just round down or up. What if we want it to round halfway? So like, say this is 2.37. If it's 373, it goes to 37. But what if we wanted like, when it's 376, it to go up to 38? The normal way you do rounding, you know. Once it's halfway, it goes to the next number. Well, that's really easy too. All you have to do is add 0.5 in here, and you can see that'll just work. And it'll work for any number of decimal places you're rounding to as well. And if you're doing ceiling for some reason, you can just minus by 0.5 and it'll do the same thing, like undistinguishable. There we go, that's math.floor. Now I should probably mention you can also just do a function for rounding. It's pretty simple. I just go Figura docs math. You can see round exists and it will just round. It's pretty simple. This is specifically a Figura math function though. Figura has its own custom math functions, as you can see here, which don't exist in normal Lua, and round is one of them. So if you're doing something else with Lua, you would have to do the other method I showed earlier. But yeah, it's definitely worth knowing about these, especially stuff like world scale. That kind of thing is so useful. There's also math.clamp. Math.clamp. This just sticks your number between 2 values, so you have your normal value, go 5, and I'll make the 2 values 0 and 10. So if my value was 5 here, it's fine, 7 is fine. If I go to 10, it stays at 10. If I go 11, or like 30, a billion, stay at 10. If I went 0, negative 14, stays at 0. Clamp, sticks you between two values. Simple. Those are some pretty useful math tools. Personally, I think this is a pretty good resource for just learning and going through the math library. There's some other Lua tutorial things here if you want as well. But I really like this site. I think it's a really good way of laying out all the information really easily. There's lots of things in here that I won't go over, but like there's math.cos, tan, sine, there's min, there's pow. You can also just do like the caret symbol, the square root, there's like inverse tan. You can do math.random to get a random number. You can do random seed to set the seed of the generator, so you can have a not random number. Convert from radians to degrees or degrees to radians, logarithms, pi, all that kind of stuff. I'd just go and look through here if you're interested. I'll have this in the description, of course. Alright, next I want to talk about return. So let me just create a function here. Call it like example log this ran. Then I need to call my function example. So yeah, this is just a basic function. We've been over this before, obviously. But I want to add into this function return. I'm just going to add an if statement to this function. So if true, then return end. So I've added this if statement to this function. Now if I run this, you'll notice that this line here no longer runs. And if I set this to false here, of course, it will still run because return never gets called. So what's happening here is the return function is being called, and then this is ending this function. So return is a good way of escaping functions, basically. Now, you may be wondering why return is in this if statement here. Couldn't we just run this at the beginning here? And no, it doesn't work. The reason is complicated. I'll explain a bit. In fact, if I did this twice, you can see the errors. Return needs to be run before an end. So whether this be an end in an if statement, an end in a loop, an end in a anything really. You can have a do end, I think. Do and return. Yeah, you can. So return always needs to be before an end. Now the reason it has to be before return is because, maybe a bit obviously, return does return stuff. And so it needs to end the function so it can return stuff, so it needs to be before an end. Let me make this function just return. And let me make this log this function. Currently it logs nothing. If I were to add a value on the end here to return, let's say this ran, you can see it runs. What return will do is it'll make the function it's inside of return this value when it's called, and it'll also end the function. That's pretty simple. Now of course you can return a lot more than strings. You can return like booleans, you can return numbers, tables, yeah, anything. Even functions, actually. In fact, returning functions is actually what happened earlier. So let's go back to the way it was before. So earlier when I did this, what this actually is returning log this ran, which is then running that function. If I run this, you can see it actually returns this ran twice. That's because this log function is being called. It's logging this ran to the chat. Log is then itself returning this ran from its function. Then we're grabbing this, putting it inside, returning this ran in an example. Then we're logging that, and we're getting that in the chat. We could go on with this forever. And yeah, as I just hinted at, return is how like all of the Lua functions and Figura functions work really. Anything that returns something. So for example, in like getPos, you'll input the model part, it'll do some fancy stuff to get the position. I wouldn't know anything about that. And then somewhere it'll just have a return for the vector3 for the position. And that's what you get from the function. So yeah, return can be very, very useful for making some fancy things with functions and organizing your code. And it's also really useful for like escaping loops and ending functions early and that kind of stuff. You might end up finding you just have like if value then return end in your script a lot of times if you want to escape. Obviously this value would be your boolean. Alright, let's move on. Now I showed you the for loop, but there's more loops than that. And I didn't show them in the first video because they will crash your game if you use them wrong. In fact, let me do that right now. While true, do end. And my game's not responding. It's super not responding. And I'm gonna need to close it. So yeah, I hope you now see what I mean. They're dangerous, but I will show you them. Just be careful. I would actually recommend going into permissions and turning yourself off of max when you're dealing with a loop. Because if you're not max, it'll just tell you that you overran the resources limit if you go into an infinite loop. So yeah, this is the while loop. It will run until this value here is false. Other than that, it's pretty simple. You can see it just runs stuff a bunch of times. It will overload your chat. Here's an example of it, just making a counter that spams your chat forever. Now, obviously, you might not want this to run forever and crash, so there's some good ways to do this. Specifically in this example, you do have value, so you can literally just like go while value is less than 100 do, and it'll count up to 100 and stop. Obviously, though, you will need this counter. Actually, this should probably be a local variable. Whoops. Another method you can use, of course, as like I discussed earlier, is return. So you could have like, if value is greater than 100, then return end. And you can see that stops. And you can put this anywhere you like in your script, which is quite useful. The issue, of course, as I discussed earlier with return, is it will escape from everything. So if this while loop is inside another while loop, or if that's inside a function, or anything, it'll escape from that and return whatever you return here, in this case, nothing. There's absolutely times where that's useful, but there's also times where that's really annoying and not what you want. So you can actually also use break. Break only works in loops. So if I put break in here, it'll do the exact same thing, but if this was inside a function or another loop, it'll just exit this specific loop and then continue on with the code after that. Personally though, I rarely ever use while loops for this kind of situation where I want to do something a set number of times. I will always just do for I equals like 100 do log I. That's much simpler and you don't need to stress about accidentally breaking out the loop or anything like that. It's also worth noting the same methods of like escaping also work for for loops. So I could go like if I equals, I don't know, 50, then return end. You can see that'll stop at 50 now, even though it's supposed to stop at 100. And you can also use break in the exact same way. Now there is actually another loop function, which is repeat. Repeat is basically an upside down while loop. Alright, I've created my loop here. It works the exact same as the other one. The only difference is it checks at the very bottom of the function, and it will only repeat if it's false. So if I made this true, you can see it would stop immediately at 1. You can see it can work exactly the same as the other one, checking and stopping in the until here. So yeah, I did the exact same thing here. If value less than 100, return. You can also, of course, do break. Exact same thing. Alright, that was just loops. Now I want to talk about order of execution and having multiple script files. Order of execution is really simple and intuitive. There's a reason I didn't explain it in the last episode. There's no point. If I run something first, it'll run first. I run first. And then if you have something after, it'll run next. I run second. That's pretty obvious, I think. It is worth noting that if you try and call stuff before you create it, it won't work. For example, if I go log variable and then create the variable after, variable equals, wow, it'll return null until you create it. Yeah. What becomes tricky though is order of execution across multiple script files, because you can have multiple script files. There we go. I have now created a second script file over here. So let's have a pop quiz. If I put in this script file, I am script 1. And then in this one, I am script 2. Which script do you think will run first? Put your answers in the comments! Nah, just kidding, please don't. That'll be really annoying. The answer is actually the first will run first, and second will run second. But that's entirely a coincidence. The order is arbitrary. That's what I'm trying to point out. If I went and renamed script 2 to say, apples, you can see now the second one runs first and the first one runs second. The order is arbitrary. This can cause some serious issues. Like say, in this script, I want to define a function. So yeah, here we have the example function. And then in apples, I want to call this log example. You can see if it's called apples, it'll error. But if it's called script 2, it'll work just fine. I'm actually going to swap these around to make things a bit more simple. There we go. So how can you fix this? It's really simple. You just need to use the require function. So if you run require and then the script file, so in this case it's called script2, save this, you can see now it works. What it does is when the require function runs, it makes sure before it runs anything else that this script runs. And then it comes back. You'll see the require function coming up a lot if you use any custom APIs from the community, because they'll need stuff to run first before you use them. Something that's also worth noting, the return function also works with the require. If I went return apples, and then log require script2, it'll return apples. I don't know what use cases this could have, but now you know. Now, require is great, but when it comes to more complicated scripts, where you have lots of different files, it can become a massive mess. That's why in normal programming, they usually just have a list, and it just goes through the script files in order of that list. Well, good news. You can do that too if you want. So this list is actually stored in your avatar.json. So first thing you're going to want to do is actually add Autoscripts to your avatar.json. So add a comma at the end here, quotation marks, and type auto, then capital S, scripts. Just like this. Follow the JSON formatting, just like the authors list, colon, space, square brackets, and there we go. Now we have Autoscripts. Now you notice, whenever I save, the script files don't work. You can no longer just have script files sitting in your avatar. You have to call them through Autoscripts or they won't run. So you can put whatever you want, and you can see it won't run, it won't error, it won't do anything. Not until we put it in Autoscripts. To do that, just put in the name just like this, script2, and then script. Now you can see that's working perfectly. And if we did it just like this, you can see it would error. But of course, we want this to run first, which is why we put it first in the list. It goes in the order of this list once you create it. Just like that. Something that's also important is if you have any of these scripts in folders. I'll create a scripts folder and I'll shove these in here. Now you can see this doesn't work. It actually gets angry because these don't exist. If you have your files in a folder, of course you need to do the file path to it, starting from your root directory with avatar.json. Our file, our scripts for inside is called scripts. So it'd just be scripts dot for both of these. And you can see it now works. You can also do a slash if you want, if you prefer that. It's up to you. It is also worth noting, let me go back into these files. If you want to use require while your files are in a folder, it's the exact same thing. So require, and then the folder is called scripts, and then script2. I spelled this wrong. Scripts. And that works. Can also support the slash. So yeah, that's Autoscripts and require. Okay, let's talk about local variables and scopes and some optimization things. I know I brought them up before, but hadn't explained them yet, so that's what I'm doing now. So when you create a variable, normally you can just access it as long as it's being created. So variable equals test. Now these variables could be accessed anywhere. You can create it and it sticks around. But what if you have a variable that you don't need to stick around? What if you have a variable that you just need to create and then throw away? Well, you'd want to use a local variable. To create one is just local variable. And you can see it seems to function exactly the same, but it actually doesn't. And that's to do with our scopes. If I created an if statement, if true, then end, put this in here, you can see now it doesn't work. That's because our variable was a local variable and was limited to within this scope, which is this specific if statement. Now we've tried to call it, but it's already been discarded. We'd have to make it a global variable for it to actually work. Scopes don't just apply to if statements, they also apply to for loops, while loops, all the loops, even just do, it works. It's also worth noting, local variables don't save between different script files. So if I had this in here, even though it's being required, it still doesn't work. Although if it wasn't local, it would. Oh, and also the big one, you can see if it's created inside a function, it's a local variable, it'll be discarded outside that function. And that also applies to tick function stuff. Events, tick. So now really comes the question, how are local variables at all useful? It just seems to take away functionality, right? Well, no. It's really, really, really good for optimization. So let's create a tick function here. events.tick. Say I wanted to log each of the players' position individually in the chat, like log player get pos.x, it's logging the x, and I wanted to log the y and the z. This is a really weird application, but you can see this does work. However, you can see we're running this one function, the player getPos function, 3 times. That's pretty inefficient. Like, we don't have to be doing that. What we could instead do is create a local variable, call it local pos, make it equal to the player position. We call it once, we get pos. And then, now that we have pos cached, we can just use this local variable that we've created. This will be much more efficient, because rather than running this function each time and Figura having to like use all its logic to get the player position, it does it once, stores it, and then uses it 3 times. This could be a global variable, and you can see it would work, but it's not particularly efficient, because it also means that you can access pos outside, which you might not want, you know. So that's one example. I think another example is something like this. This code won't work, by the way. I've just dragged it from somewhere, so that's why it's dying. You can see I did a bunch of calculations for one thing with a bunch of booleans. I did a calculation for a bunch of other things. I put them together in an if statement, and then I broke from a loop if either of them were true. You wouldn't want these to be global variables. You want these just to be throwaway data. It's also worth noting, this applies to functions too. You can have a local function. Local function, I don't know, example, and turn true. Put this in here. You can see when I try to run this, it doesn't work because it's local. If it's global, it does work. If your functions are local, it'll be more efficient, more optimized. That's only useful if your functions don't need to be accessed anywhere else, or you don't want them being accessed anywhere else. Next up we have some, well, I'll be honest, it's more maths. So, with lots of functions within Figura, you'll see vector3. If we log it, you can see it comes up in yellow with these 3 values. That's kind of like a table. And it does have table elements. It has x, y, and z. Can call it by x, y, and z. This is what I was just doing literally just before. You can also just do like 1, 2, and 3 if you want. That works as well. And in case you're dealing with like RGB values, there's also RGB instead of like x, y, z, and that kind of stuff. But what this is a vector. Whenever you're dealing with multiple numbers together in Figura, it'll be a vector. If you're retrieving like a model part's position, it'll return a vector3. Like even if you just set a model part's position, you can see one of the inputs is a vector3 with all 3 values. Vectors are a massive part of Figura's APIs, and they'll come up everywhere. So it's important to know about vectors. Now, this is a maths lesson. I'm not going to explain all of the math stuff to do with vectors. In the context of Figura here, it's literally just a table that has either 2, 3, or 4 numbers, because Figura only supports that. Alright, first let's look at creating a vector. It's super simple. You can just go like log vectors dot, and you choose which vector you want. In this case it's a vector3, vec3, and then you do your 3 numbers. So I'm going to go 1, 2, 3. And you can see there's our vector. If I were to do a vector 2, it'd just be the same with less numbers. Vector 4 is the same. Now, you don't actually need to specify which kind of vector you're working with. If you want, you can just do vectors.vec and remove the number, and you can see it works fine with all your types of vectors, although it won't work with like a vector with 5 numbers, because like I said, Figura doesn't support that. There's also this vec shorthand. So, if you want, you can, instead of having vectors.vec, you can just do vec, and you can see that will just work. In this state, you can't specify which type of vector. Vec3, you'll see just errors, but that's fine. It does just work for all the different types. So there you go. You created a vector. Now, what can you do with that? Let's look back at the APIs. So it's just the normal vectors API. You have a bunch of functions you can do with different types of vectors. Now, a lot of these are just useful utility functions, like, for example, hex to RGB. You get a hex string, vectors dot hex to RGB, and then go like A67 to EF. They'll return the RGB values. The Vectors API here just has a lot of different useful things like that. Convert to HSV, load to screen space, just some useful stuff so you don't need to do a bunch of maths yourself, really. But then you also have more utility you can do in here in the actual vectors component. You can actually do maths between different vectors. So I could do, say, vec 1, 2, 3, add vec 3, 2, 1, and you can see we get 4, 4, 4. I'm pretty sure in this specific case, you could also just do addition like that, yeah, but not all of those work. For example, clamp won't work, floor won't work, all that kind of stuff. Here's something that's good to know. You can actually use a hash to tell how long a vector is. If I go hash, you can see it says it has 3 entries. If I made it 2, it'd have 2 entries. And if I made it 4, it'd have 4. This also applies to tables. So if I went, I don't know, just create a new table here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see now it says that this table has 10 entries. Make sure you know about that one. That's good to know. I didn't know about that until recently, actually, which is embarrassing. The final thing I want to talk about vectors is just vector swizzling. Sounds complicated, but it's really simple. So I have my vector here. It's simple. It's just vector 1, 2, 3. But what if I wanted to rearrange that? Sure, I could do something like this, and you can see that works just fine. But there's a much easier way to rearrange these kinds of things. And yeah, that's obviously with vector swizzling. So all you have to do is, at the end of your vector here, just type the order of your vector values. In this case, it would be z, y, x. And you can see that rearranges it, just like that. You could have multiple of the same, or you could actually do a different value, like that's blue from RGB. This will work with all the different types of vectors. And it's also worth noting that if you put an underscore in here, it will just make it 0, which can be quite useful. Alright, time for the end game boss, matrices. So if vectors is basically just a table, a matrix is basically a table of tables. It's an array of numbers. I mean, you've definitely seen it before. It's just like a table of tables. Oh. Here, one of these things. Again, this isn't a maths channel. I'm not going to explain to you how matrices work. Go to Khan Academy or something. But I will show you how to use them in Figura. Matrices are used in some more advanced things. Like, for example, you can use a matrix to get the position of your model part in a world. Or you can use a matrix to get your camera position. If I go to the docs here, you can see it's pretty similar in terms of structuring. You have just some generic things here, and then you have your specific types of matrices. A matrix 2 is a 2 by 2 matrix, a matrix 3 is a 3 by 3 matrix, and a matrix 4 is a 4 by 4 matrix. Matrices are nowhere near as simple as vectors. Even just creating a matrix is a little bit wacky. So if I go log matrices.mat3, here you can see it creates just an empty matrix. You can see you do have the option to choose the colons. So if I were to go like vec 1, 2, 3 and just do that a couple times, you can see that would work. And I just made it a variable to make things easier. Now when it comes to indexing from a matrix, it's not as simple as just, of course, like 1, 2, or 3, x, y, or z. But it's not too bad. First, you need to choose your column or row. You can see it's determined with C or R. You can see on a matrix, the bottom ones are the columns and the side ones are the rows. So like row 1 would be 6, 10, row 2 would be 5, 3, and then column 1 would be 6, 5, 0, column 2 would be 10, 3, 2. So if I called R1, you can see get a vector, that's 1, 1, 1, R2, 2, 2, 2, R3, 3, 3, 3, C3, 1, 2, 3, C2, C1. You can also just do 1, 2, or 3, and they'll just do the columns. Now, you can also access the individual values from the matrix. That's pretty easy as well. If you have a look here, you see next to the co's and rollums, there's also the v's, and it has 2 values. Basically like a coordinates value on the matrix. So v11 might be your first value, 1, 2, 1, 3, then I go 2, 3, 2, 2, 3. Pretty simple. Now, I'm not actually going to delve any deeper into matrices because if I just tried to explain how these functions worked, like raw with just numbers, it just wouldn't make any sense. You kind of need an example for explaining matrices to actually, like, explain anything. which is what I'm going to do with my next episode when I explain particles and sounds. There's some matrix applications there which can be useful. That will be it for this episode though. Thank you so much for watching. I know this was probably an exhausting watch. Just basic scripting in maths is super annoying, but I do hope it's able to help, even if it's just a little. My next video should be coming soon, considering I already recorded and then decided I need to make this video first. Thank you so much for watching, and I hope to see you in that video. See ya!